Let me tell you about Molecular Plasma Group, which is a startup I have been very recently involved in. So it's all very fresh to me, and I'm actually very happy to be able to present this new venture. We're located in Luxembourg. So this is the little country that's somewhere between Germany, Belgium, and France, and the Technoport. And so we're Molecular Plasma Group, so let me just remind you what plasma is. Plasma is really the fourth state of matter. Actually, 90% of the known universe is composed of plasma. And plasma is a highly energetic medium, which is a mixture of ions, electrons, free radicals, but also a lot of neutral species as well. So the concept and the idea behind the company is that if we can control plasma, if we can use this highly energetic medium to initiate reactions with a wide range of molecules, we can actually functionalize surfaces with chemistry that was not really available or feasible without this technology. And plasma coating and plasma technology is not really new, but since we're dealing with a very reactive and a very energetic medium, we can't really control what comes out. So people tried a lot of different things. There are technologies that are known. There is the corona plasma, which can give you the temporary increase of wettability or adhesion on your surface. But it's really limited in terms of the substrates and the molecules that you can use for it. In general, plasma, you can also achieve permanent increase of certain surface properties. But again, you can't use any more complex molecules because as soon as you put them into the plasma, they just decompose, fragment, and you end up with a chaotic layer of something that you cannot really characterize. And the technology that we have is low energy plasma, which allows you to try a variety of liquid and gaseous precursors that you can use to achieve a permanent and customized functionality on your surface. And we're not limited to gases and we're not limited to siloxane compounds, but we can really use a wide range of polymers. In terms of the technology, let me just tell you briefly a bit more about the concept. It's a high voltage system where you use high voltage to generate plasma. So we co-inject a gas, which is our plasma medium, a plasma source, with precursor molecules of choice. And the plasma activates these precursor molecules of choice, and when they're deposited on the substrate, which is really one of the electrodes inside the system, we can achieve a certain coating. And the advantage of this low energy system is that we mostly maintain the integrity of the precursor. So if you put a more complicated molecule than ammonia, you actually preserve the molecule and you can polymerize it on the surface. And the big advantage for the chemical industry of this process is that there is no solvent emission, there is no water contamination. So it's really a clean system where you avoid a lot of highly energetic and very energy-consuming and time-consuming steps in the chemical industry. Things that we can achieve, just to list a few examples. There's a huge interest in adhesion and release of substrates on composite structures, on fibers, on textiles, for example. So we really use a wide variety of systems. We can actually do biomolecules to achieve antimicrobial treatments on the surface, to start playing with tissue engineering. And some of the more classical examples are superhydrophobicity. So you're all familiar with surfaces that are super hydrophobic from which water droplets just bounce right off. And these things can be used to exercise, for example, anti-corrosion coatings, or to improve the icing or wetting. So there's really a wide range of things that can be done. So how do we actually go about it? Because you can't go to a client and say, hey, we can do everything. Can you give us a problem? We actually started with an idea of a system that has been built. So this is a physical device that's in our lab. This is one of the test devices. And we developed three types of lines. Here you can actually see the plasma treatment happening, with which we can treat different types of surfaces. And let me just give you maybe two real-world examples of things that can be done. Okay. For example, if you imagine car components, you have a lot of different materials that need to be combined into one, with which you need to really reach high adhesion so that your car doesn't basically collapse when you shut the door, or that when you have impact. And with this co-development with one of our clients, we've reached basically a 50% increase of the adhesion force between coated steel and polyethylene system that they were interested in. Another example is how to improve adhesion between aluminum and polyurethane. And then you're going to ask me, why would you do this? And what's the real life example? So this actually went into outdoor LED panels, which had these types of structures in them. And the problem was that very quickly they would take in water and electronics would be short-circuited. So all of these beautiful LED panels that were put outside would just break very, very quickly. So one of the things we've done is that with our plasma treatment, we could really improve the sealing and adhesion between these two materials. And now these panels have a much increased lifetime, so they can actually be operational for longer. A very visual example is, for example, how to reach a fire retardant coating. So you can burn cotton. Normally it burns very, very quickly. With a customized coating, you can get something that resists fire for much longer than you would usually expect. So what's our approach? What we do is we do a stage gate process of co-development with the client, with the customer. What happens is that the customer comes to us, or we come to the customer, and we start the discussion. What's the formulation? What's the property that you would like to achieve? What are the materials that you're using, and what is it that you would like to do? Then we see whether we can actually do the chemistry on this type of coating. So we start with a discovery date, for which we prepare the chemistry, and the client comes with their own product. And within one day, we basically do a test coating, which they can test in their and prove in their own lab to see whether they're interested. And then we do joint development along the line with the client. That starts with formulation, that continues with formulation and optimization, and it basically ends with installing one of our production lines inside their facility. So this is a very complex and long road, from starting with really actually defining what they want to do, and ends with a production line at their own facility, which we then help to maintain, service, etc., etc. These are some of our key partners in Luxembourg, Belgium, and around. And yeah, thank you for your time. And we really don't know ourselves the scope of the technology, so basically we just ask people, hey, give us a task, and we'll see if we can help. Thank you.
Thank you very much, Joanna. Questions? So a short one, because we're kind of running out of time. Like, what is the corporate stage of the startup you're working at?
So we're actually fully on the market right now, and we're ready to deliver. We have about 40 something projects that are in development at the moment, and they're starting from this zero stage of defining a function, of finding out whether actually we can help, and we're actually having 2 projects at the industrial line level as well. So obviously it's a funnel because it's not for everyone, but we do get to the end with certain people as well.
So one of the applications you mentioned, organ on chips, is it already commercially available?
No, so this is the newest development that we actually just got a grant for last week. That's working jointly with the University in Leuven to do a quick antibody immobilization step or process. And so far we had really good results, and this is one of the more research-oriented focuses at this point.
The last one and the short one.
So I'm not sure if you covered that. So to start a startup with an expensive plasma generating device, I guess it's expensive. So can you tell us how did you start and where did you get the money from?
Yeah, this is a very good question because yes, we do need expensive equipment. We have expensive equipment. We sell expensive equipment. The chemistry itself is not cheap, and the whole company idea came from joining 2 projects, and one was an industrial project in which an attempt was made to manufacture these plasma lines, the plasma devices, and that was in the Netherlands. And in Luxembourg, there was a part of one of the research institutes that was interested in just the chemistry. So one guys were doing the application, and then someone else was doing the machinery. And then with basically help of external investors who are very much actually involved, so part of the company, these 2 ideas were pulled out from both research institutions and were brought together. So for example, a whole patent array was bought back from these research institutions to be able to combine both concepts and actually make it market ready and commercialize it.